Function notation is something that's very important in calculus. It's really just a notation. So really you just have to make sure you understand what it means. It's not really any new math, it's just how we write and understand math. But we use it a large amount in calculus. So for example, if I have something like f of x is equal to x squared plus 6, well, this is exactly the same thing as if I said y is equal to x squared plus 6. There's really no difference. The reason we like it in calculus is because this one gives you just a little bit more information. It tells you that x is the variable. But, I mean, you might say, well, don't we know x is the variable, right? We have x squared plus 6, right? Well, what if we had something like this? What if we said f of x is equal to x squared plus a? Well, which one is the true variable? It turns out that what we mean by this is x can change. Now this might be a little confusing, and I wouldn't worry about this too much because you'll learn more about this in calculus. But x is the variable, meaning it can change. So given a scenario, x will change. Like if you were to throw a ball, time would change as you throw the ball, right? But this value here for a given scenario is the same. We call that a constant. So it's actually, while it is technically a variable, it's a constant variable that never changes. If you look at a situation where you throw a ball, like say I throw a ball from some height here, and it flies like this, as time goes on, we are changing that. So that would be the variable. But we throw it from a given height. I could call that height A, for example, and A would be constant. Throughout this entire time that I've thrown the ball, A doesn't change. It's the same. But time does change. So there's a little bit difference between an x variable and an a variable in this function notation. It's telling you that a or x is what changes. Whereas if I were to write f of a equals x squared plus a, that means a completely different thing. It tells me that x is actually constant. It's some variable, I don't know what it is, but whatever it is, it doesn't change, whereas a does. Now I've kind of gone off on a tangent there. I apologize for that. Don't worry about all this stuff on this side too much because you will learn all about that in calculus. But getting back to the actual function notation, this f is just telling you what is there. Now, we could change it, right? Like if I were to give you like what is f of, well, x is just a variable. You can replace it with anything you wanted. So like what if I wanted to say what is, given this f here, what is f of b? Well, f of b would just be replace x with b. So we'd have this x squared plus 6. I like to write it like this parenthesis first, just to show that, hey, we throw in anywhere we see that, anywhere you see an x, you throw in a b. So that is what function notation looks like. What is it? I could also say, well, what's f of 2? Well, that's just going to replace x with 2. That'd be 2 squared plus 6. Well, we know order of operations, so 2 squared is 4 plus 6 is 10. That is f of 2. In fact, we could plug in anything you wanted here. So one thing that we're often going to plug into calculus, sorry we're getting a little busy here, we'll finish this up very soon, is you might want to find what is f of x plus h. That comes up all the time in calculus, is finding f of x plus h. Well, it's no different. We just replace x with whatever's in that parenthesis. So we have x squared plus 6. So we just plug in this x plus h there. That is f of x plus h. And then you'd have to do some foiling for that and simplify. Okay, now that we have an explanation of what function notation looks like, let's do an example. Here we're given a function. We have x squared plus 2x minus 3. And we want to find this complicated looking thing. This is f of x plus h minus f of x over h. Now this is actually something you will, I pretty much guarantee you will be doing this in calculus. This is probably the number one reason why someone fails calculus is because they can't quite handle this algebra, this exact algebra we're seeing right here. So let's do it. So we need to take this one piece at a time. So first, let's find f of x plus h. So f of x plus h, just like we did before, that's going to be our x squared plus 2x minus 3. But inside of there, we'll plug in x plus h. Okay. So now we better simplify that down a little bit. So if we look at this first part here, that's going to be a squared. We have some x plus h times x plus h. We need to FOIL that out. So we'll have x plus h times x plus h. That gives us x squared plus an xh plus another hx. So there's actually two of them, plus h squared. So if you're not familiar with foiling, I'm not truly covering that here. But feel free to just Google that if you need more help. It's called FOIL. Take a look for that. But this part gives us that. Then we're going to distribute this 2 to this part. So we have a 2x plus 2h as well. And then, of course, we just have that minus 3. So that means that we have, let's see, f of x plus h is going to be, if we combine like terms, we have an x squared, and then we have a 2xh, and an h squared, and a 2x, and a 2h, and a minus 3. I guess we didn't combine any like terms because there weren't any, but that's okay. So then we subtract f of x now, right? This whole thing right here is just f of x plus h. So we'll subtract f of x. So that's going to be x squared plus 2x minus 3. Be very, very careful about this minus sign. People mess that up because make sure we have to distribute that minus to each part. So you want to be careful that you put those parentheses there. But then what I'm going to do is notice that we have an x squared minus, let's do this in another color here. We have an x squared minus another x squared. We have a 2x minus a 2x, and we have a negative 3 minus a negative 3. So drop that parenthesis there. Those just cancel each other out. So if I divide this by h, all we have is, let's see, we have the 2xh plus h squared plus 2h over h. Everything else went away. So now if I can continue simplifying this, we can factor out an h. We're left with 2x plus h plus 2. And there's still an h in there. The h's cancel, and we get 2x plus h plus 2. Great. So that is f of x plus h minus f of x all over h. Now, I'm not going to tell you what this means in a calculus perspective because, well, you'll learn all about that in calculus. Just know that you will be expected to be able to do these kinds of things in calculus. Now, because I think this is just insanely, insanely important, let's do one more example that's very similar to this one. Here we have basically the same question. We have f of x is equal to 2x plus 3, a different function, but we're still going to find f of x plus h minus f of x over h. So we'll start off again by just saying, what is f of x plus h? Well, we take the 2 times the x plus 3, but we replace x with x plus h. Now this one's going to be a little simpler because we don't have to square it. So we'll do 2x plus 2h when we distribute plus 3. That's it. Much more simple. So we'll take that 2x plus 2h plus 3, and we'll subtract the original f of x, which is 2x plus 3, and then divide by h. Now, just like before, we have some things that go away. That's 2x minus 2x goes away, and 3 minus 3 goes away. So we just have 2h is all that's left in the numerator. When we divide that by h, it cancels, and this is just 2. Now this is interesting because, now disclaimer here, if you don't want to learn any calculus, you could just drop this part, don't worry about it. But there is a direct relationship to this number of 2, which, if you remember, is the slope of a line. Now I will talk more about that slope of a line, but there is definitely a relationship, that there's a reason that we ended up with that slope of the line, and you'll learn all about that in calculus. But for now, I think that's all I want to teach about function notation. It is, I would say, the single most important topic you should learn before you take calculus.